Hi there, welcome to my channel. This is Bhakti. Today we will learn chapter number 3, Atoms and Molecules of class 9th Chemistry. In this part 1 we will cover topic of atoms. So let us start with the beginning. It is given that Indian philosopher Maharishi Kanad, he said that anything, any material, any padarth that can be divided into smallest indivisible particle, okay, and that is known as Parmanu. In English, Parmanu is known as atom. Okay, we know it as atom. And what is atom to us? Atom is smallest indivisible particle. Atom is the smallest indivisible particle. We cannot see it, can't be seen by naked eyes. We can't see it by our naked eyes. They are extremely small and we cannot even divide it. The radius of atom is about 10 to the power of minus 9 nanometer, which literally means 0.000000001 nanometer. Okay, so 0.00001 nanometer. So this was all about atom. Then second thing that we learn in this chapter is about law of chemical combination. Laws of chemical combination. See, these are the laws of chemical combination which are given by Anthony L. Lavoisier. So this is the person who gave the law of chemical combination. So there are basically two laws. First law states that, what is the first law? It is of law of conservation of mass. So this is the law of conservation of mass, in which he states that mass can neither be created nor be destroyed. Means we cannot even create mass and we cannot even destroy it. It remains as it is. And what is the proper statement of this law? The proper statement of this law is, okay, the total mass of the reactants would be equal to the total mass of their product. Now let's say we are having two reactants, that is hydrogen and oxygen, and the product that we get is H2O, means water. The mass of hydrogen is, let's say, 2 gram, and the mass of oxygen is, let's say, 16 gram, and the product, and this is their product, this is their addition sum. So the mass of this H2O, it would be 18 gram. Why? Because see, 2 plus 16 is what? 18. And the mass of these reactants, when we will take up their sum, we will get 18 gram only, and thus 18 gram is equal to 18 gram. So mass is neither created nor destroyed, it remains as it is, and this is nothing but conservation of mass, where this is the reactant, this is their product. Now let us move to the second law. Second law is quite tricky but easy only. Law of constant proportion. Sorry for the disturbance, it was the aeroplane. Constant proportion. Now here in this law, what they state, if you want to make water, then you need, water is compound, okay? Water is compound. If you want to make water, then you need element. What are the elements you need? You need hydrogen and oxygen. But this hydrogen and oxygen should be mixed in a proper amount, then you will get this compound. Like if you take like it is in 1:8 ka ratio. So if you take 2:8 or anything, again it's aeroplane, sorry. If you take any kind of ratio, then you will not get water, you might get something else. Means you will, of course you definitely will get something else. You should have them in a proper amount. Like 1:8 ka ratio is there, then it should be in 1:8 ka ratio only, or else you will get something different. So this is nothing but law of constant proportion. The proportion, or like 1:8, the proportion should remain constant. It should not vary. It should not vary actually. So this was all about law of constant proportion. In the chemical substance, the elements are always present in a definite proportion by mass. So this was the law. Like for example, if you take one example, like CO2, I mean carbon dioxide. In this also you need 3:8 ka ratio. 3:8. 3 and this is 8. So 3:8. So this is the ratio that is fixed by mass. Its statement is, in chemical substance, the elements are always present in a definite proportion by mass. After all this thing, you have Dalton's atomic... Oh, where's my pen? Sorry. Dalton's atomic theory. So this was the theory which was given by Dalton, in which several assumptions were made by him, and there was also drawback of his theory. So what he said is, very first thing that he said, matter is made up of atom. So this was the this was the first thing which he introduced. Matter is made up of atom. Then we have second thing, atom is smallest particle which can't be divided. We cannot divide atom. Then third thing, he said that atom of various elements have different mass. Let's say I'm having one element, hydrogen. Various elements, hydrogen hai, helium hai, lithium hai, beryllium hai, and etc etc. So these all will have different mass. And the second one, atom of same element will have same mass. Atom of same element will have same mass. Let's say I'm having hydrogen. Of course, yeah, they are same only now. And H2O. Then the mass, like here the mass is, let's say, 1 gram. Then the mass of this hydrogen would be 1 gram only. Next thing that he told is, atom is whole. Atom is whole means it is not like in fractional form. Like you have hydrogen, 1.5 hydrogen is to 1.8 oxygen. No, it is not like that. It is like totally incorrect. It is whole, like 1:8, like this. Then the last thing that he said, number of atoms are constant in any compound. The number of atoms, they are constant in any compound. Now I am having this water compound. So the number of atoms, let's say it is 1. Here oxygen is 8. So this will remain constant. ठीक है. So this was all about the Dalton's atomic theory. Now let's see what were its drawbacks. Drawbacks of Dalton's atomic theory. So very first thing, he said that all atoms have same mass. He said all atoms have same mass. He said atoms have same mass, but atoms of, he said that atoms have same mass of same element. I forgot to write that. Wait a minute. Same element. As I told you, if hydrogen is having 1 gram, then in H2O or in any other thing, in this H2SO4, in any of the thing, it will have mass of 1 gram only. But this was totally incorrect. But instead, atom of same element can have different mass. Okay, different mass. Let's see how. Example, you're having carbon. Carbon is the very best example for each and everything. Carbon you have, so the carbon particles, they are in the form of C12, C13, C14. Now there are so many things, so they have different mass. So this was the first drawback. Okay, first drawback. The second thing that Dalton said that atom of different element have different mass. Atom of different element have different mass. Atoms of different elements have different mass. He said atom of different element have different mass, but this was also wrong. Why? See, here you have potassium, which is 40 gram is the mass, and you have Ca, which is having 40 gram mass only. This potassium is different, calcium is different. We know both are different, but their masses are same. So how can you say that it is wrong and all? And the third drawback is, he said atom is indivisible. He said atom is indivisible, but this is wrong. Atom is divisible. Atom is divisible. We can divide atom in 3 parts: electron, proton, and neutron. Don't mind the spelling. Electron, proton, and neutron. You can divide atom. So how you can say that atom is indivisible? It can be divided into subatomic parts. These are known as subatomic parts or elements, anything. So this was the third drawback. Okay, have the topic atoms. So we know that smallest particle of an element that take part in any chemical reaction is atom. Atom is the smallest particle of an element that take part in any chemical reaction. It cannot be seen through microscope, and very much important thing, atom is always found in spherical shape. Okay, it is always sphere like this. Atoms are always arranged like this, sphere. ठीक है? The radius of atom is known as atomic radius. Its radius is known as atomic radius. And what is the atomic radius? It is 1 nanometer. Okay, which means 10 to the power minus 9 nanometer. And yeah, this was all about all the characteristics and everything of atom. Another important point, the particles of atom. I mean, the atom is very small, but atoms are arranged at particles. Therefore, atom are arranged in a certain way. They are arranged in a certain way. Like, let's see, let's say this thing. It is arranged in a certain way. It is not like anywhere here, there, except gases. There are also exceptions, bro. Molecule rich in electron. Molecule. Here I am talking about molecule rich in electron. Electron means negative charges. Okay, an electron is highly reactive. Let's say I am having this thing and which has so many electrons. Okay, which has so many electrons, and in between there is this proton and neutron. So it has so many electrons. It has very high valency. Then it is very reactive material. You know which are the reactive materials? Carbon. Carbon is extremely reactive. Like any noble gases, not noble gases, they don't need anything. Any not reactive material gets immediately attracted to carbon. Why? Because it is highly reactive. Now it is having so many electrons, so it can attract anything towards itself. It is must to have 8 electrons in last shell. It is must to have 8 electrons in last shell. Then what we have, so this was all about our atom, and here I will show you the atom of carbon. Here you have positive, you have a neutral. Now you have this. They are arranged in a certain pattern. Now why you may see it in any video. This may not be the correct one, but I'm still randomly drawing it on my own for first time. So this is the atom of carbon. Carbon. See now, the atomic number of carbon is 6. Atomic number of carbon is 6. Now what do you mean by atomic number of carbon is 6? It means it has 6 electrons. It means it has 6 electrons. Okay. Now the next topic is electron negativity. This is the new concept to you guys, so you should hear it very carefully. Oh yeah. So see, it says that what is this electron negativity? It means elements have capacity to attract. It means electrons have capacity to attract electrons towards them. It means elements have capacity to attract electrons towards them. The capacity of elements, thus the capacity of elements to attract other elements electron is known as electron negativity. Now what I said, did you understand anything? So I said, let's say this is an element of hydrogen, so it is attracting the electrons of another. It is attracting the electrons, it is attracting the electrons of other elements towards itself. This is known as electron negativity. The word itself says ना, the electron negativity. मतलब एक एटम के पास कैपेसिटी होती है दूसरे एटम के इलेक्ट्रॉन्स को अपनी तरफ अट्रैक्ट करने की. बट वाई डू एलिमेंट अट्रैक्ट अदर्स इलेक्ट्रॉन, पर क्यों उस एलिमेंट को दूसरे एलिमेंट की इलेक्ट्रॉन को अपनी तरफ अट्रैक्ट करना होता है? तो उसका वेरी वेरी बेसिक रीज़न है टू फुलफिल देयर नीड्स और टू बी स्टेबल. लेट्स से एक एटम है जो कि पॉजिटिवली चार्ज्ड है, एक एटम है जिसमें बहुत ही कम इलेक्ट्रॉन्स हैं और वो पॉजिटिवली चार्ज्ड है, और एक एटम है जो कि नेगेटिवली चार्ज्ड है. नेगेटिवली चार्ज्ड मीन्स इट हैज़ हाई नंबर ऑफ इलेक्ट्रॉन्स. ठीक है. सो इफ now why this is positively charged? Because it is having high number of positive thing. And why it is negatively charged? Because it is having high number of electrons. But if I want to make this stable, I need to attract electrons. अगर ये पॉजिटिवली चार्ज है तो मुझे और नेगेटिव चार्जेस ऐड करने पड़ेंगे इसको स्टेबल करने के लिए. अगर ये नेगेटिवली चार्ज है तो आई नीड टू अट्रैक्ट प्रोटॉन्स. वाई? टू मेक इट स्टेबल. ये आयंस है ना, अभी ये आयंस हो जाएंगे. व्हाट इज आयन? आयन इज एनी चार्ज पार्टिकल, कैटायन एंड एनायन. ठीक है. कैटायन मतलब पॉजिटिवली चार्ज, एनायन मतलब नेगेटिवली चार्ज. तो ये आयन है और इन आयन को मुझे एटम में कन्वर्ट करना है, तो उसको स्टेबल करना है. इन द सिंपल लैंग्वेज आई वांट टू मेक देम स्टेबल. सो ऑफ कोर्स आई विल कैंसल द चार्जेस, राइट? एंड बाय कैंसलिंग द चार्जेस I will get the stable atoms. Then these both would be stable. So this is why the electron negativity is there. This is why the electron attracts other electron towards itself. ठीक है. Now here boron. I'll give you one example of boron. तो ये होता है बोरॉन और कि यहाँ पे होता है पॉजिटिव 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 चार्जेस. अगर मैं बोली व्हाट इज बोरॉन इज 2:3 मीन्स 2/3. व्हाट इज 2/3? ये होता है के शेल में, ये होता है एल शेल में. के शेल इज दिस मीन्स 2 नेगेटिव चार्जेस here in K shell, and in this means 3 negative charges in this shell. Still you can verify the image, verify the structure. Don't depend on this. I am drawing anything, I mean this thing, rough one. Okay, don't verify, don't blindly believe this. Verify the structure. Okay.